Okay, let's go through this. I know I didn't give you a lot of time to do this, and if you're not done, that's okay. First one, circumference. That's the formula that we talked about yesterday, and I said if you don't know this, you absolutely have to know this. The formula for circumference is 2 pi r. So if the radius is 1, we have 2 times pi times 1, or just 2 pi. Leave it in exact form if you can. Okay, so instead of saying 6.28, leave it as 2 pi. Okay, the length of a 180-degree arc. So picture your unit circle. Take a look at it right now. 180 degrees is what part of that circle? What fraction? It's half, right? Half of 360 degrees. And you guys know that by looking at it, but we can show that by this fraction. 180 divided by 360 is 1/2. So if we want the arc, we want 1/2 of the circumference. So 1/2 of 2 pi is pi. Do you guys see that by 180 degrees on your unit circle? Yes, right? Okay, length of a 45-degree arc. So now we need to know what fraction of the circle 45 degrees is. Okay, will be pi over 4 once we get there. 45 over 360 simplifies to what fraction? You guys simplify it. 1/8. Yep. And so we have 1/8 of 2 pi, which is 2 pi over 8, simplifies to pi over 4, just like Maggie said. Okay, do you see pi over 4 at 45 degrees? Yeah. Okay, 45 degrees is pi over 4 radians. Same deal with 210. 210 divided by 360, I can divide by 10. I can again divide by 3, which gives me 7/12. I multiply that then by 2 pi, that gives me 14 pi over 12, or 7 pi over 6. Which again, you should see on your unit circle next to your 212 degrees. Now, why are we doing this? Because you have all of this on your unit circle, right? But is 117.9 degrees on your unit circle? No. So we're going to use this same idea that we've been doing this whole time. We're going to take our angle measure and divide it by 360. And multiply it by the total length around the circle, 2 pi. Grab your calculators for a second. 117.9 divided by 360 gives me this decimal. But it'd be really nice if this was in fraction form instead of decimal form, right? So I think most of you know that you can go to math from here. And there's your fraction button right on top. I want to convert my last answer to a fraction. And so I have 131 over 400 times 2 pi. And I want to simplify that. Well, I can simplify the 2 over 400. 2 over 400 simplifies to 1 over 200. So in exact form, my answer would be 131 pi over 200. Okay, that would be the arc length for that corresponding angle. Questions? Now, if you did those problems, you just found the first formula that we need for the second part of 13.2. Okay, so this should not go in your unit circle. This should go in your notes. Arc length, for whatever reason, I can't give you an answer to this, but they're going to call arc length S. So if you ever see S, that's what it's talking about. Part of the outside of a circle. Okay, that's what arc length is. So you guys just found out that you took the fraction of the circle that we're talking about, and you multiplied it by the length around the circle. And we're multiplying it by length because that's what we're looking for. Does this formula look a little familiar from yesterday? Fraction of the circle times something. Okay, it's exactly the same for all the formulas that we're going to do. You wanted to convert to degrees yesterday, you did the fraction of the circle times the total degrees in a circle. You wanted radian, you did fraction of the circle times the radians in a circle. Same idea. So what does that look like mathematically? Well, we're going to have theta, whatever our angle measure is, and we're going to divide it by either 360 if we're talking degrees, or 2 pi if we're talking radians. And we're going to multiply it by the length around a circle, which is called the circumference. And you guys know this by now, that the formula for circumference is 2 times pi times r. Okay, take a minute and read through this example here. Okay, I read this is a little confusing to me. So, first thing that we should clear up is arc measure. Arc measure is another way to say angle measure. However, the angle is this measurement in here, and the arc is the measure around. Okay, but we would give the units the same way. So we would say that either way, that's 2 radians. And so we can also label that as theta. Radius of the circle is 3. We want the length of the arc. We want the arc length. Okay, so instead of in radians, we want a measurement this time in centimeters. Okay, so let's write down what we know. S equals, for arc length, our theta is 2 radians. So if it's in radians, should I use 360 or should I use 2 pi? 2 pi. So 2 divided by 2 pi times 2 pi r. And r we know is 3. Now, before we start multiplying this together, do you see anything that would be nice and easy for us to cancel? 2 pi and 2 pi, right? And so we can do that. And answer is going to be 2 times 3, which is 6. In units, centimeters. 6 centimeters. Okay, so what was the question really asking? Let's look at this picture over here. We know that our arc measure is 2 radians. And what that means is I can fit 2 of the radii around in this arc. And if we know that the radius is 3, remember from yesterday that 1 radius equals 1 radian. So each of these radians would be 3 centimeters. And so if I add that up, that total distance is 6. In picture form, it looks really easy. In words, maybe not so much. Okay. The nice part about this formula is if you are using the formula with radians, so you have 2 pi on the bottom and 2 pi here, that's always going to cancel. And we can't just get rid of that because if you use 360, that doesn't happen. Okay, questions on that one? Okay. Next formula that you're going to talk about is for the area of a sector. So if you think of a circle like a pie, the area of a sector is like a piece of that pie, like the green part or the purple part of the circle up there. Look at your formula. Area of a sector is going to be fraction of the circle. Same thing that we've used in the other three formulas. But this time we're looking for area, so we're multiplying by area. Okay, so fraction of the circle, theta, divided by, depends again on degrees or radians, so 360 or 2 pi, times, what is the formula for area of a circle? Well, yep. Okay, so if you don't know that one, that's one that you want to circle, star, highlight, underline, whatever you're going to do. This won't be given to you. That's something you need to know. The area of a circle. Okay, so read through the example. So this time we're looking for the area of a sector. Make sure you read carefully to know if you're finding area or arc length, because you're going to have problems with both today. Area of a sector with radius of 5 and central angle 2 pi over 3. So this is theta. Fill in to our formula what you already know. Okay, so I know theta, 2 pi over 3. I know that I'm in radians, so I have to divide by 2 pi, not 360. And I know my radius is 5. Okay, this part right here, we end up with this weird complex fraction again, so let's get rid of that. Let's simplify that. Remember that this is 2 pi over 1. And dividing is the same as multiplying by the reciprocal. So I'm going to write that instead as 2 pi over 3 times 1 over 2 pi. Now before, again, you go multiplying and combining things together, look for things you can cancel. So again, in this problem, our 2 pi's cancel out. And we don't need to use our calculator on this. Your book is going to give you decimal answers. Leave it in exact form. It's better in exact form. So simplify what you can. Across the top, I have 25 pi. Across the bottom, I just have 3. 25 over 3 doesn't simplify, so that's going to be my answer. Okay, don't forget about units, though. We're talking area. And we have measurements in centimeters. So how should I give my units? Centimeters squared, exactly. Area is always going to be squared. And arc length is always just going to be that unit. So it would be centimeters in the previous problem. Questions on that one?
Can you put it in decimal form?
You can put it in decimal form. I think on the quiz, I think I asked for exact form. So unless it asks for exact form, it doesn't matter. But just make sure you know how to leave it in exact. Other questions? Okay, so this second part goes through these two formulas, and then it throws in this random piece here that wants us to evaluate these trig functions. So grab your unit circle because we're going to be using this. And when it asks you for these, it's going to ask you to evaluate and give an exact form. But then it's going to say, if possible. So we need to figure out if it's possible or not to give this an exact form. So first thing I want you to do is go to your calculator. And in 13.1, I asked you guys to go into mode and change your mode to degrees because all of the calculations we were doing with sine, cosine, and tangent were all in degrees. Today we're going to be talking radians, so switch it back. You want your mode to be in radians. And then plug in for me the cosine of pi over 4. If you didn't get this answer, it means you're not in radians, so make sure you are getting this. Now, this isn't exact form. Even though your calculator gives you so many decimal places and it stops, it doesn't mean the number actually stops. It means your calculator's run out of space. Okay? So this isn't considered exact form, but we can find the answer to this in exact fraction form. So the first thing that we need to do is convert this pi over 4 to degrees. So use your unit circle. Find pi over 4 on your unit circle. And find the corresponding degree measure. And pi over 4 should be 45 degrees, right? Which is a special angle. Remember we talked about those special angles, 30, 60, 90, 45, 45, 90? Let's draw a triangle that is 45, 45, 90. And fill in the side lengths that you know. So in 13.1, we talked about there being a 45, 45, 90 triangle that does have side lengths 1, 1, square root of 2. And we can use this triangle to evaluate the exact value of cosine of 45. So I'm going to use one of these two angles, and it doesn't matter which one, as my reference angle. Then I'm going to label the sides accordingly. So over here, this would be the opposite, adjacent, and hypotenuse. And you think back now, think to SOHCAHTOA. And cosine was what over what? Cosine. Yep, adjacent over hypotenuse. So I need the adjacent side over the hypotenuse. And we said that the adjacent side was 1 and the hypotenuse was the square root of 2. But we need to rationalize that. So we're going to multiply by the square root of 2 over the square root of 2 to get the square root of 2 over 2. Okay, grab your calculators again and plug in the square root of 2 over 2. Which is the exact form of the answer that your calculator gave you when you did the cosine of pi over 4. Questions? Okay, let's try another one. So, again, using your unit circle, find pi over 6. And pi over 6 is 30 degrees. And so we're going to draw, this time, a 30, 60, 90 triangle. And fill in your sides. Okay, so remembering back to 13.1, opposite your 30 is 1. Opposite your 60 is the square root of 3. And opposite the 90-degree angle, or the hypotenuse, is 2. Okay, so think SOHCAHTOA again. Sine is what over what? Opposite over hypotenuse, right? And our 30-degree angle is our reference angle. And so the opposite side would be 1. The hypotenuse would be 2. And so our answer is going to be 1/2. Now this is one of the few cases that we actually could have plugged it into our calculator and got an exact form. So try it. Do the sine of pi over 6. And you're going to get 0.5. Okay, you guys work through this one. Okay, so in this one, pi over 3 is 60 degrees, which is going to use the same triangle as the previous one, but your reference angle is different. Now we're using 60 instead of 30. Okay, so cotangent. Well, first we need to think probably cotangent is a reciprocal of what? Tangent. And tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. So my adjacent side in this one is 1. My opposite is the square root of 3. And again, I'm going to rationalize. And so I get the square root of 3 over 3. Let's check in our calculator. So grab your calculator. Plug in the cotangent of pi over 3. Are we confused? Okay, good question. So notice on your calculator there isn't cotangent, right? There's just the 3 basic trig functions, sine, cosine, and tangent. Don't use the second feature up above. That's actually to solve for angles. What we want to do instead is use the reciprocal idea. So we're going to do 1 divided by the tangent of pi over 3. And if you plug in the square root of 3 over 3, which we found as our answer, that's going to be the same value as what your calculator gives you. Questions on that one? Okay, one more problem. Find pi over 9 on your unit circle. There is no pi over 9, right? Okay, so in the problem when it says give an exact form if possible, this one's not possible to give an exact form. This is a calculator problem. So grab your calculator again. And notice that cosecant is not in your calculator. So cosecant is the reciprocal of which trig function? Sine. So you're going to do 1 over the sine of pi over 9. And this one you're going to have to round. Like I said, there is no exact form. So the book would probably give 2.92 is their answer.